Welcome back to part 2. Now for this one, I want you to start off by solving this problem on your own. You're going to put in your answer, check your answer, and let's see if your answer is correct. Go ahead and pause the recording while you do this. Alright, here we go. A 4 by 400 meter relay race in which 4 different team members each run a 400 meter leg race. The total distance ran by one team is 1,600 meters. And the problem wanted to know how many total kilometers does the entire team run. So we have to take and convert the 1,600 meters into kilometers, also known as kilometers. And to do that, we need to look at our conversion chart. Our base unit is going to be meters, and there is 1,000 meters in a kilometer. And now we have the information we need to start solving this problem. So I'm going to use dimensional analysis to solve this. I'm going to say that I am starting out with, let me get my marker here, 1,600 meters over 1 times. Now remember, your meters have to be in the bottom, your kilometers are going to be on the top. That way the meters will divide each other out. There is 1,000 meters in 1 kilometer. From here, we can take and divide out the meters. So I'm going to make those two go boom. They are gone. And we're going to multiply what's left. 1,600 times 1 is 1,600 kilometers over 1 times 1,000 is 1,000. Now we can divide out the zeros there just like I've taught you, and that is going to leave me with 16 over 1, but that's not enough. I'm sorry, 16 over 10, but that's not enough. So I'm going to come off to the side. I'm going to divide 16 by 10. I'm going to say that 10 goes into 16 1 times. 1 times 10 is 10. Annexing my decimal and my 0, the decimal goes up and the 0 goes down. 10 goes into 100. Whoops, what did I do wrong? Oh, I'm sorry, I put that in the wrong spot. That's going to give me 6 left over, and there we go. 10 goes into 60 6 times. 6 times 10 is 60 with nothing left over. So now my final answer is 1.6 kilometers is how far they are going to end up running. Is that what you put in? Is that the correct answer? Let's find out. 1.6, check my answer, and we have success here. Excellent. To convert between customary and metric units of measurement, we're going to use equivalent ratios or dimensional analysis once again. And some of the relationships are shown. Now you can see this big old table of relationships here, and we're going to take a screenshot of that so I have it to refer back to. But I do need to point out this talk about it thing down here. This squiggly looking equal sign, that is your about sign. And we use an about sign because 1 inch does not equal 2.54 centimeters. It's pretty dang close to 2.54 centimeters. Oh, you could say it is about 2.5 centimeters, but it is not equal to it. Now suppose you wanted to know how many grams are in 11 pounds. Well, if we went back to what we had before here, you could see, hold on, that 1 pound is equal to about 453.6 grams, and we would use that conversion factor that you can see right here in order to solve it. Now we're going to take a minute and break it down, and I'm going to show you where they got those numbers from. I do really hate how your textbook makes some big leaps of understanding, so we're going to take and figure out where it all is coming from. Now, first thing to point out, let's get ourselves a nice pretty color here, like we're going to use green this time, is that we had the conversion ratio. We looked at that on that chart a minute ago. They said 1 pound is equal to 453.6 grams. And you can see that right here in the first part of the conversion ratio. 1 pound is equal to 453.6 grams. We have 11 pounds, and we want to know how many grams that is. So from that, we took to go from 1 to 11. That was taken right here. 1 times 11 was 11. Therefore, we're going to have to take the 453.6, multiply that times 11, and when you do, you're going to get approximately 4,989.6. That is what they got right here. So the number of grams is going to be the 4,989.6 grams. That means that 11 pounds is going to equal to about that number. Shavesh is using square tiles to make a mosaic mural of the Lotus Temple in India. Each tile is 1 centimeter long and the mural is 50 inches wide. We want to know how many tiles would each row of the mural take. We want to think about it. It says, will Shavesh need more than 50 tiles or less than 50 tiles? Well, if you think about it, each tile is going to be 2.54, I'm sorry, each tile is going to be 1 centimeter. The whole mural is 50 centimeters long, so since there's 2.54 centimeters in an inch, and we can see that conversion factor once again right, let me find it here, right here, you've got that conversion factor that says that 1 inch is 2.54 centimeters. Because of that, you know you're going to have definitely more than 50 centimeters. You're going to have 2.54 times 50 centimeters. Now, there's two different ways to work this. The first way is going to be to use the equivalent ratios. So using the equivalent ratios to work it, let's lay out what they actually did here, because your textbook has a bad habit of just throwing down answers without explaining it to you. So we're going to start off with our magic pen, and we're going to acknowledge that right here there's 2.54 centimeters in 1 inch. And that is about, because it's an approximation, 50 centimeters, I'm sorry, some unknown number of centimeters is equal to 50 inches. Now, if we were to take it from there and go back to this right here, how did they get from 1 to 50? Well, they multiplied 1 times 50 to equal 50. Therefore, to go from 1 to the 2.54 to the number of centimeters, they're going to have to multiply 2.54 times that same 50, and when they do, that's going to become exactly 227.0 when you multiply it. But even though that is an exact multiplication, your answer is still going to be an approximation, because we're approximating 2.54 centimeters per inch. But anyhow, that right there is where they came up with their answers right there. It says there's 124 centimeters in an inch, therefore he would need 124 tiles. Method 2, using dimensional analysis. Now for that one, we're going to scroll up and then we're going to see what it all looks like together. Now this is how they showed their work. Remember, I like to show my work a little bit better, so I'm going to write it as 50 inches over 1 times your 2.54 centimeters over 1 inch. Notice your inches are cattywampus of each other. I can divide out my inches here and here. They're gone. And when you multiply the 50 times the 2.54, is the same 127 we got earlier. 1 times 1 is 1, and the only unit left is a centimeter on top, meaning you get the same 127 centimeters that we had before, and that is going to end up going in our answer document. Right here you can see where they worked through it. They did the same simplifying, just not as pretty as mine, and got the same exact answer. Either way you solve the problem, you get the same answer. I would like to point out that either way you do, you're going to have to show your work. I've got 2 different methods shown here. Both of them, I've got good quality supporting work justifying my answer. You can't just throw down an answer. If you give me an answer without supporting work, you will have done it just for what? That's right, you would have done it just for fun. Now it's going to be your turn. Read the problem, work through it, submit your answer. Let me know what you get. Alright, let's take a look at this. A raisin weighs about 1 gram. Jabril wants to buy a half-pound bag of raisins. About how many raisins are in a half-pound bag? Well, the first thing I need to do is figure out how many raisins are in a pound bag. And you can see we've got a conversion factor that says 1 pound is equal to 453.6 grams. So my target is going to be 1 pound of raisins. Okay. Times the conversion factor. Pounds has to be on the bottom, so it'll divide out. Grams will be on the top. And there is 453.6 grams to 1 pound. Now, of course, my pounds, let's do something pretty here. The pounds are going to divide each other out just like that. And we'll put a 1 under there. When I multiply it out, 1 times 453.6 is 453.6 grams over 1, also known as just 453.6 grams. Now, that's only halfway there. We haven't actually found the answer. We know that each raisin weighs about 1 gram. So we could say that is equal to 453.6 raisins. But did we want, it's an iron raisin, did we want a whole pound of raisins? We did not. So we're going to take that number and divide it by 2. So now I'm going to take my 453.6, divide it by 2. 2 goes into 4 2 times. 2 times 2 is 4. Nothing left over. Bring down the 5. 2 goes into 5 2 times. 2 times 2 is 4. With 1 left over, bring down the 3. 2 goes into 13 6 times. 2 times 6 is 12, which is going to leave 1 left over. Bring down the 6, your decimal goes up, and 2 goes into 16 8 times. 8 times 2 is 16 with nothing left over. So the actual answer is not quite going to be 226.8 because you can't have 0.8 raisins. We're going to call that 227 raisins for our final answer. Let's plug it in here, see if we are right. 227. I'm going to check my answer, and it is indeed right. Now, once again, I do want to point out, guys, that's showing your work. That is what I must see. If I see anything else, you will have done it just for fun. Let's move on to the next problem. Red is training for a 500-meter race by swimming 1.5 miles a day. How many meters does Red swim each day? What conversion ratio should you use for this first conversion? Well, that one sounds like we may have to use more, so we've got to go from meters to miles. So let's see, what are my options here? Well, I have a mile to a kilometer. That's an option you can see right here. And I have meters to feet. So I think what I'm going to do is I'm going to start off by changing either miles to kilometers or meters to kilometers, and we're going to move from there. The problem, you can see they set up by doing just what I suggested, changing miles to kilometers. Let me show you what they did. Now you can see, just like I said right here, they've got 1 mile is equal to 1.61 kilometers, and 1.5 miles is equal to some unknown number of kilometers. From there, they said, well, what do they have to do as far as conversion factor goes to get from 1 mile to 1.5 miles? That you can see right here. They multiplied 1 times 1.5 to get 1.5. Therefore, 1.61 times 1.5. When you multiply that out, you're going to get approximately 2.415. And that is where they ended up getting this value here. And what unit is that? That unit is going to be kilometers because your K value right there was kilometers. So far we know that they have gotten 2.415 kilometers. We need to find out how many meters he goes. And that led to step 2. In step 2, we acknowledge that 1 kilometer is equal to 1,000 meters. You can see that in that comparison. and we know we have 2.415 kilometers, and we want to know how many meters that is. So we have to ask ourselves, what did we multiply by 1 by right here in order to get it equal to 2.25? Well, they multiplied it by 2.415. They multiplied by 2.415. Therefore, to find out how many meters it is, they had to take that 1,000, multiply it by 2.415. And multiplying by thousands are easy. You've got 3 zeros, so we're going to go bloop, bloop, bloop with our decimal to get your final answer, 2,415 meters that you see right here. And it is going to be meters because the m value is meters, so our answer is going to be listed in meters. Now I do want to point out how much work was involved in that. You had 2 steps that you can see right here, and you did have to complete both of those steps in order to solve the problem. You must give me some good quality supporting work. That's a pretty big amount of work for doing using the ratio method. Let's look at it using dimensional analysis. Now we're going to try the same thing using dimensional analysis. Now for dimensional analysis, remember you got to carry your units all the way through, and they totally miswrote what they have here, okay? I started doing this recording and it totally freaked me out because it says here the ratio of kilometers to meters is 1.61 to 1. That's not correct. What it actually is put a line through that, miles. The kilometers to miles is 1.61 to 1, and you can see that they actually have that set up right here, 1.61 kilometers to 1 mile. Now when I work it, I do like to put them both in as fractions. 1.5 miles is what we're starting out with over 1. We're going to use a conversion factor that says that there's 1.61 kilometers in 1 mile. The miles are going to divide each other out, and when you multiply your 1.61 times your 1.5, you end up getting 2.415. The miles are gone. All that's left is the kilometers. And there we did the entire problem in one step. We did not have to do all that other funky stuff that we did before. We did the entire problem in one step instead of doing 2 steps. See how much less supporting work you had to use using dimensional analysis? For me, this is a much better way to go. But we're not done. See, we found kilometers, we need miles. So now we need to set up another problem with dimensional analysis. Well, let's change our color for this one to a pretty shade of blue. 2.415 kilometers times, of course that's going to be over 1, there is 1,000 meters in 1 kilometer. Once again, my kilometers are going to divide each other out. When I multiply this number times 1,000, I get the same 2,115 I got before over 1. The only unit that's left is meters, so that's the same thing as saying 2,415 meters for your final answer. Still a lot less work here than using the ratio method. Dimensional analysis is the way to go, and it's definitely what you're going to be using when you start getting up into 7th grade and beyond. We are very quickly running out of problems on this one. We're at resource 10 of 12, but we are going to stop this recording because I don't want it to be too big, and we will come back and finish this problem about African elephants in part 3.